Okay, graphing quadratic inequalities in two variables. So we did linear inequalities, now it's quadratic inequalities. So quadratic inequality, just like linear, can be expressed in one of the following four forms. Y is less than ax squared plus bx plus c, less than or equal to, greater than or equal to ax squared plus bx plus c, where a, b, and c are real numbers. Okay, so we know that ax squared plus bx plus c is a quadratic function. Well, y equals would be the graph, which we've spent a little while studying, and now we want y is less than or equal to. So the graph of a quadratic inequality in two variables will have a parabolic border, right? So it's the shape of that quadratic. Solid or dotted, which one is solid?
Equal to, less than or equal to.
Yeah. So the one that's less than or equal to, greater than or equal to. If it's strictly less than or strictly greater than, there'd be a dotted border, and will be the region either above the parabola or below the parabola, right? So in the last lesson we had a line separating the plane into two regions. Now we have a parabola separating the region. All right, is 2, 7 a solution to the inequality y is greater than 3, x minus 5, quantity squared minus 20? Justify your answer. So what are we going to do for this? Sorry, what did you say? Substitute? Put in the x and y values for the coordinates and see if we get what? A true statement. Okay, so if it's true, then we know that it is a solution to the inequality, and if it's false, then we know it is not a solution to the inequality. So go ahead, do it. Stick in your x and y, and see if what you get is true or is not true. Okay, so true or false? False, right? 7 is not greater than 7. 7 is in fact what?
7.
Equal to 7. So, okay, this is false. So what does that tell us about the point 27 then? What could we say about it?
It's on the parabola.
It's on the parabola, right? Okay, because if that were greater than or equal to, or if it were just equal to, then it would be a true statement. Okay, so that point is on the parabola, but it is not a solution to the inequality where all of our y values must be greater than the corresponding y value on the parabola. Okay, so what are we going to say? It is 2, 7 is not a solution. So 2, 7 is not a solution. And you kind of need this in your solution, right? Like you can't just go to here and do that, and it's like, okay, so what, right? Like, what have you done? Like you think, oh, I've shown it, right? It's obvious, isn't it? Yeah. No, you've done something and you've come down there, but state it. Okay, so make the outright no. Look, it's not on there. It is not a solution, and here's why. Since this is false, this is not a solution. Right? Doesn't take that long to just write that out, right? Just say, no, look, I'm answering this. Use transformations to sketch the graph of. All right, transformation. Okay, so transformations should be listed in order. What is the order of transformations? Vertical stretch, reflection, horizontal translation, vertical translation. Okay. Now, could be vertical translation, horizontal, right? So it doesn't really matter. So it's stretches, reflections, translations. Okay. So we're going to use transformations. every time I see a particular transformation, then what I want to do is I want to write it out in words, right? I want to list it in words. And that way, if I'm working with, there's questions where you say, what's the image point? Well, that means that you can just take the original point and apply the words to it, right? Like, oh, I'm vertically stretching, so I'm going to multiply the y coordinate with this. And then I'm, doing this, and so on. And that gives me my my image point, because that'll be on the quiz, right? We're definitely going to give you, here's the transformation, here's the point on the original, what's the image point, right? Where does it end up? That's what we're asking. Where does it end up? So describing in words is a good thing. Okay, so number one, we have a vertical stretch by a factor of 2 about the x-axis. What's number 2? We have a reflection in the x-axis, right? What's the third one? Okay, horizontal translation, which way, how much? Okay, 3 units right. And lastly, what's the last thing we got? 7 units up. So translations need 2 things, right? Well, 3 things, I guess. I mean, which kind of translation? Is it horizontal or vertical? And then we need to know how many units which way. So you can't just say horizontal translation 3 units. Or you can't just say horizontal translation to the right. Okay, you have to say it's a horizontal translation 3 units to the right. Okay, now, which of these transformations affects, okay, wait, before we do that, where's the vertex of this? Okay. Which of these transformations affects the vertex of the original? And remember, the original is y equals x squared, right? That's what we're always starting with. Does the vertical stretch affect the vertex?
No.
No. Does the reflection affect the vertex?
No.
No. So the only thing that affects the vertex is these guys, right? So where is the original vertex? 0, 0. And where is it now? 3, 7, right? So we can look at that. And we know that even by looking up here, right? So we can do this a couple of ways. One is, well, we could do the words. We can also look here and say, all right, 3, 7 is where the vertex is, right? This is why that's where it is, right? Because it moved to the right and it moved up. And this doesn't affect, right? Because 0, 0, double the 0, right? You still get 0. Reflect the 0, you still get 0, right? If a point is on the line of reflection, then it doesn't go anywhere, right? It just stays there. If it's on the mirror, then that's where it is. Okay. All right, so we got a grid down here, right? Okay, so what are we going to do? Well, oops. So let's put our vertex down, 3, 7. Which way do we open? Down. And we are vertically stretched by a factor of 2. So if I move 1 unit this way, where should I go? 2 units down. Okay, and by symmetry, then I'm going to do that on the other side. If I move 2 units this way, how far? 4. So we were at 7, that'll take us to 3. Did I go to, okay, right. 1, 2, 3, 4, right. And by symmetry, same thing other side. If I move 3 units this way, how far? Try again. 9. 3 squared is 9, right? Yeah, we got it squared. It's not going to look very parabolic, right? So if you did go 6, at some point you should realize, wait a sec, right? Like, it just doesn't look right. And if I move 4 units this way, how far? 16. Oh, wait a sec, though.
Stretch by 2.
Stretch by 2. So that's all wrong. Good thing you're using pencil. All right. If I move 2 units this way, should be 4, but it's stretched by 2, so it is 8. See, I knew something was wrong. 8th. You should speak up. Move 3 units. Should be 9. 18. Okay, be off the grid, right? So we can't do that. There we go. That's better. Right, and then just don't let, I mean, this is 3 units away, and 18 units would be like negative 11. It's like down here somewhere. So just, like, don't cut through that line. Kind of keep it within the 3. There we go. That's better. It's horrible. You can't, trust me, you can't draw on it unless some of you guys are good drawing. You're going across the light, so you're drawing in the dark. All right, so we used our transformations, right? And ultimately, what do we want to do? Oh, we want to sketch the graph of y is less than or equal to. So where is less than or equal to going to be? Below the parabola. All right, are you sure? Well, let's try a point. Okay, so we could try 0, 0, right? If we try 0, 0, we expect to get a false statement, right? So we're saying, okay, well, try 0, 0. Okay, 0. 0 minus 3 is negative 3. Squared is 9. Negative 18. Plus 7 is negative 11. 0. Is 0 less than or equal to negative 11? No, I think it's bigger. Okay. How about the point? Now, we might want to be a little smarter, right? That works nicely with linear. Let's say, how about we choose the point 3, 0, right? Because if we put a 3 in here, what happens? Well, it just zeroes out, right? So 3 minus 3 is 0 squared. We end up with a 7. The point was 3, 0. So 0 less than or equal to 7? Yeah, I think 0 is smaller than 7. Okay, so that is in the region. Yeah, so now we know, yeah, we are shading below the parabola, which is what this says anyways, right? But there's no fancy rearranging here, because this isn't in a form of like ax plus by equals c, where you can't tell, right? You know, so if I say x plus by is less than 12, that's hard to tell. Y is less than or equal to, 7x plus 2, easy to tell which region. Okay, so we are shading the region below, and we have verified. And let's do one of these guys, a highlighter. No, that's just a pen. Shading. Anyway. Okay, so anything in this region is a solution, and anything outside is not, right? So you could do the point, where x is 0, y is, again, what's easiest to choose, right? When it's x minus 3, it's easy to choose x is equal to 3, right? Zeroes out one of the terms for you. Okay, this guy, y is less than, what kind of a line am I going to draw when we draw the line? Dashed line, right? Okay, so we need to draw this, right? Now, in essence, we in a sense, we didn't have to do this. We had to keep this in mind, right? But I think still, there's lots of space. Doesn't hurt to write it out. It's good practice when you see a transformation to just, write it out. Doesn't take long. How do you graph that? Oh, we have to do that completing the square thing, right? Okay, so completing the square. I'm going to do 2 things for you, because I like you. I want you to do well on the test. I have, so I gave you the review sheet, right? Everybody here got the review sheet? All right. I have a video, full solutions review sheet. It's like 40 minutes long, right? Like seriously. It's every question done, fully detailed, answered, everything you could possibly want to know about that question, okay? And I'll stick it up in there. I also have a video on an alternative method of completing the square. Right. It's the one where you actually, instead of doing it on 2 lines where you're going back and forth, you kind of just work your way down. Right. So you add 16, you subtract 16. Right. You see that on the line, and then you pull it out. So if you want to watch that one, you can as well. right? So some of you had problems with completing the square and you just say, I don't get that method that you showed, then go look at the other method, right? It's not long, it's like 15 minutes, it does like 4 examples, okay? And if none of those work, find something else somewhere else, right? And then just come to me before Monday and say, is this an okay method for completing the square? I mean, heck, if doing it on 2 lines where you just sort of, then pretty much any other method is probably going to be an okay method for it. Just coming up with the answer, not showing anything else, that might be a little hinky, but at least a couple of lines worth. Okay, so how do you complete the square? So what we're going to do is we'll do y equals 1/2 x squared plus 5x plus 8, right? So that's what we're going to graph, and when we do it, we're going to graph it as a dotted line. Okay. Now to do that, we got to get it in vertex form, so we know where the vertex is, what the transformations are. And we do know which way does it open. It opens up, and it is, how does it relate to, is it narrower or wider? Yeah, so it's wider than y equals x squared, right? It's vertically stretched by a factor of 1/2. Okay, which can help us in plot. So when we move 4 over, we should be 16, we're only going to be 8, right? Half of. Okay, so what do? We go 1/2, and we go x squared, and then what goes next? Plus. So what's the magic number here?
5/2.
Well, if you did that, but I want half of something is 5. So it's going to be 10. Right? I'm factoring 1/2 out. So think about it. When I put the 1/2 back in, it can't be 5/2 because 1/2 times 5/2 is 5/4. It's 10x. Okay? So check that, right? I mean, otherwise the rest of the steps are wrong. So how do you check that? Just multiply it back in. You got 1/2 x squared plus 5, right? If you roll 5/2, you'd be going, I got 1/2 x squared plus 5/4. Get out the eraser. So you are dividing by 1/2, which is multiplying by 2, right? Yeah, I don't like dividing by fractions either. So just say, I have to divide this by 1/2, I gotta divide that by 1/2. No, let's just multiply by 2, so 10. Okay, so we go 1/2 x. What do we write now? Plus 5, right? So we've got the plus sign from here. Plus is coming down. We take 1/2 of 10 is 5. That's going to be squared. Okay, then we go back up a line. What do? So we got to square the 5, get 25. So we now put, so what is this? X plus 5 quantity squared is x squared plus 10x plus 25. Okay, and then we can say, well, this is going to be minus 25, but times 1/2, right? So don't forget the 1/2 because it's 1/2. Now, what the other method is going to show is you're going to write like x squared plus 10x plus 25 minus 25. Then you'll go down a line. You'll take out the 1/2 of the minus 25. Okay, so in some ways it's more steppy, right? So there's a couple more steps, but it might make more sense to you. It might be easier for you to do, so then do it that way. Okay, so go watch that. If you're good with completing the square, you got 4 to 4 and that, or you know that, oh wait, I was supposed to do something and you can fix that, then go with that method. All right, so what does this end up as? What do we got? Minus 9/2, right? So I'll do that up here. So this is plus 16 over 2 minus 25 over 2. Okay. And we like fractions. I'm not going to, if you put minus 4.5, whatever. But if it's thirds, don't write it as a decimal. Okay. So if it is a terminating decimal, like 4.5, okay. But if it's a non-terminating decimal, thirds, sixths, ninths, whatever, then you got to leave it as a fraction, right? Or just leave them as fractions. All right, so we don't have to write it out, but just for the heck of it, let's write out the transformations, right? Not really required for this question. You know how to graph that, but just write them out just so you get in the habit. Because next year, trust me, you're gonna be doing a lot of that. You're gonna look at transformations. You're gonna have to, in words, describe what the heck's going on here. So, you know, doesn't take much, right? So VS. And say where it's stretched, right? I know it's about the x-axis. You know, we can go over here too, right? Which vertex is at 3, 7. And here, where's the vertex? Where's the vertex? Just in the interest of finishing this. Okay, so we're going to draw that. Vertex is at -5 and -9 halves. 4.5. If I go over 1, I go up a half. That's actually quite doable because we're at 4.5, right? So going up a half just takes me to, sorry, we're -4.5, takes me to -4. If I go over 2, I should be going up 4, but half of 4 is 2. 1, 2, 2. 3 is 9, half of 9 is 4.5. That's kind of actually handy, right? Because we're 4.5 below, so this will just put us on here. And then going over 4 would be up 16, but half of that is 8. So 1, 2, 3, 4, 5, 6, 7, 8 at 3.5. And by symmetry, then we're over here. Got lots of points. Fill the grid. Arrows on both ends. And I realized that just after it would be a dotted line. Man. Maybe I can just, yeah, no. Damn it. Okay, I'm going to pause this because I got to get all my. There. And you draw a dashed line, and where are we shading anyways? What, was this greater than or less than? Because I switched it to the dashed line there, and it makes it thick. You don't have to draw a really thick line. It just has to be dashed. Where are we shading? Inside here or outside there? Outside there. Which means 0, 0 should be in the shading region. But again, 0, 0 is not always the best choice. Well, it's okay here, right? So 0, 0 leads me with, okay, so remember this was y is less than, whoops. Okay, so we're really doing, oh man, it's gonna thick on me now. Really doing this. So if I put 0, 0 and I get 0 is less than 8, which is true. Yeah, good. 0, 0 is in the region that I want. And I need a highlighter. I think one of these would be a highlighter. Yeah, well, I don't know what I'm doing.
Oh, yeah.
Okay, you got the idea? You got pencils, you can do a very nice shading job with pencils. Shade the whole region, don't just, like, honestly, if on your paper you don't indicate any shading here, you can expect to lose 2 marks, right? Like, don't just shade it, you've got to shade the rest of it. It doesn't have to be dark, you don't have to use up half the pencil or anything like that, right? But you need to indicate that, look, I've shaded everything that is not inside here. Okay. And whoops, I mean, you can try a point inside here just to, well, what would be a good point? So -5, 0 would be a good point to check there, right? That should be false. So I put a -5 in here, I get 0. 0, I get 0 is less than -9/2, which is not true. Okay, so that's good. Determine the inequality that describes the graph shown. All right, so how do we do this? We say, well, what form are we going to use? Standard form, vertex form? We use vertex form, right? So even though we're doing inequality, this is a very good review of just, I'm going to give you one of these probably and just say, hey, what's the equation, right? So you start off with, all right. Okay, here's the equation I'm using, right? Y equals ax minus p squared plus q. And here's what I know. Okay, what do we know? Well, the vertex is at -3, 8, and we've got a point here at 0, 5. Okay. So I'm going to say y equals ax plus 3 squared plus 8. Okay. So what I've done is indicated the point of the vertex, which is PQ, substitute in my PQ. Now I'm going to substitute in the point that's on the parabola, which is 0, 5. Now, we know that, let's see, if you go 1, 2, 3, and down 4, it's not worth. Here you go. If I go over 3, I should be going down 9, but I'm going down, so it's really like -4/9. So let's just work it out so we can show algebraically that it's -4/9. Okay, so we're going to put in the point 5. Excuse me, for y, and 0 for x. And we get 5 is 9a plus 8. -3 is 9a, and so a is -1/3. Okay, that makes sense, right? Because if I went over 3, I should have gone down 9, but I've gone down 3, so it's 1/3, and it's going down. Okay, now we can write the equation y. Now it's not equal to, right? So is this less than or equal to, or greater than or equal to? Or greater than or less than? Greater than, right? So we're less than, it would be inside the parabola. Okay, so y must be greater than. So all the values in the shaded region are bigger than the corresponding y value on the, right? That's what you're looking at, right? If it's shaded above, it's greater. If it's shaded below, it's less. So y is strictly greater than -1/3 x plus 3 quantity squared plus 8. Okay, so y is strictly greater than -1/3 x plus 3 quantity squared plus 8. Okay, questions? Comments? So a lot of this just echoes, right? Stuff that we've already done. It just, okay, now we're just throwing in this inequality sign. Okay, one more, I think, yeah. A microphone has a parabolic reflector attached that directs incoming sounds to the microphone. You've probably seen them at sporting events, guys walking around with these parabolic microphones, right, and they point it, and then because of the parabolic shape where you're seeing satellite dishes in the shape of a parabola, and what they do is they focus the incoming sound or radio signals at a point, which can then be picked up by a receiver, in this case the microphone. Describe the region that a microphone can cover if the reflector has a width of 50 centimeters and a maximum depth of 15 centimeters. Okay, so, and this is page 493, example 3. So we've got a width of 50 centimeters. And a depth of 15 centimeters. We want the region this thing can cover. So what we need to do is put down a set of axes. Bless you. And you have a choice, right? So it's placing the vertex, really. So we could put the vertex here, 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 here. Any particular choice? In the middle. Yeah, I kind of like it, you know, so okay. So let's. That makes P and Q easy, right? Because what's P and Q? They're both zeros, right? So all we're really getting is an A value, which is the shape of this thing, right? So remember, A changes the shape, right? Makes it narrower or wider. In this case, it looks like it's going to be a lot wider. Okay, if that's 0, 0, then what's this point? So this is going to be 25, and this is going to be negative 25, and this up here is going to be 15, right? Okay, so 0, we've got a depth of 15, we've got a width of 25, or sorry, 50, so we have to go 25 either way. So this is the point 25, 15. Okay, so we know we're dealing with this. It ran out of ink. I know, but it ran out of ink. Okay, so we know P and Q are 0 and 0, right? We're just dealing with y equals ax squared. We're going to plug in the point 15 is equal to a times 25 squared. So 15 is 625a, and a is 15 divided by 625, which reduces, and we should reduce these things, so what, 3 over 125? So the equation is y equals 3 over 125 x squared. But we want the region. And so the region is going to be, where, down here? No, it's going to be up here, right? So the region is going to be this. So what are we going to say? Y is we'll say greater than or equal to, right? Because it includes, you know, greater than or equal to 3 over 125 x squared. This has to be paired with that diagram, okay? By itself. So if all you did was write that stuff down, no diagram, you're looking at, yeah, I don't know, like 1 out of 2 marks maybe, or half the marks at most. Because it's meaningless without the diagram, right? Because somebody else who placed the origin here is going to have, now, their A value is still 3 over 125, right? That has to be, it's constant. In the sense that everybody has to get that for its shape, because the shape doesn't change. But based on the vertex, maybe it's 3 y is greater than or equal to 3 1/25 x minus 25 squared, right? Or whatever, because the vertex has been placed somewhere else. So your answer has to be, has to meet with a diagram that is appropriate. All right, and if you look at 493 example 3, they probably did it differently. You may. Okay. Never a question. Okay, we're done, right?